Welcome to Algebra 2 with Mrs. Bibb. These notes are for my honors class and for my regular Algebra 2. We are in week 20. We are going to be learning about the quadratic formula this week. Please complete your warm-up. We'll work on the practice in class if you're an in-person learner. And if you're not an in-person learner, you can work on the practices at home, and please message me if you need help with anything. The quadratic formula. Instead of solving by factoring or solving by completing the square, you can also use the quadratic formula. And the quadratic formula is below. Down here is the quadratic formula. I like to sing a song with the quadratic formula, and I don't know, I guess it'll be fine for me to sing it on the video. At some point, I will tell you that you can earn 5 points extra credit for singing. You have to sing it to me, the quadratic formula. And that's my in-person and remote learners as well. So it will be to this tune of Pop Goes the Weasel, and you sing x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here's the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's singing the quadratic formula to Pop Goes the Weasel. There's a great rendition on YouTube to an Adele song. It's two students, I guess it was one of their assignments to actually do the quadratic formula to a song. And I usually show that in class, but I probably won't this year. But if you want to look it up, if you're interested, then please do, because it's really good, especially if you like Adele. The discriminant. The discriminant is the value under the radical. I'm going to highlight it. b squared minus 4ac. I want you to get into your brain that when you see b squared minus 4ac, that's the discriminant. And this value, when you work it out, this value tells you the number and nature of your roots. So this tells me the number and nature, meaning like what they look like, of your roots. On the next page, I believe, we discuss more about the discriminant. We're going to name A, B, and C first. For number 1, A is 1, B is -7, and C is -18. I'm going to do the discriminant, b squared minus 4ac first, so I can tell what my solutions will look like. -7 squared minus 4 times 1 times -18. 49 plus 72 is 121. And this is greater than 0 and a perfect square. So then I know I'm going to have two real rational solutions, and I will not have a radical. So I'm going to sing the quadratic formula for you. I'm so sorry if you don't like it. You can fast forward or turn off the sound. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now let's fill in the quadratic formula. So x equals negative b, so 7 plus or minus the square root of. We already know this value of the discriminant. That's why I like to do it in this order. We know this value right here. It is 121, so that's what I'm going to put here. All over 2 times 1. So x will equal, I have to simplify that radical, 7 plus or minus 11 divided by 2 times 1 is 2. Then to find my two solutions, x equals 7 plus 11 divided by 2, and x equals 7 minus 11 divided by 2. 7 plus 11 is 18. 18 divided by 2 is 9. 7 minus 11 is negative 4. Negative 4 divided by 2 is negative 2. So my two solutions are negative 2 and positive 9. Moving on to number 2. To use the quadratic formula, just like when you're factoring, you have to make sure that your equation equals 0 first. So I'm going to subtract 4w and add 1. I like to keep my a value positive. That's why I did not subtract w squared. A is 1, b is negative 4, c is 1. I'm going to do the discriminant, b squared minus 4ac. b is negative 4 minus 4 times 1 times 1. So 16 minus 4 is 12. So 12 is greater than 0, and it is not a perfect square. So that means I'm going to have two real irrational roots, which means I'll have a radical in my answer. Fill in the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative b is 4. We'll sing that in class one day also. So warm up your vocal cords before you come to class. Let's see. B squared minus 4ac is this value here. So that's what I'll put under the radical here. So the square root of 12 divided by 2 times 1. So x will equal 4 plus or minus the square root of 4 times the square root of 3 over 2. X equals 4 plus or minus the square root of 4 is 2 times the square root of 3 over 2. Then I need to simplify. I need to check this number, and this number. Do I have a common factor that I can divide by? Yes, I do. I want to divide each of these by 2 because that's my common factor. So x will equal 2 plus or minus square root of 3 over 1, and I don't have to put that 1. So that's my solution, 2 plus or minus the square root of 3. You are welcome to separate that into two solutions. You do not have to. Into 2 minus the square root of 3 and 2 plus the square root of 3. That's totally up to you. Either one of the ones that I have down there are acceptable. Now let's look at number 3. I'm going to add the 4z squared and add the 3. And I understand if those of you that add 7, but you know I like to keep that a value positive. So that's why I added 4z squared and added 3. A is 4, b is negative 7, c is 3. Do the discriminant first, b squared minus 4ac, negative 7 squared minus 4 times 4 times 3. So 49 minus 48, that's 1, greater than 0, and a perfect square. So that means that it is two real rational solutions. And let me get those. The quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And let me see, fill it in. Negative b would be 7 plus or minus the square root of 1 all over 2 times 4. So x equals 7 plus or minus 1, because the square root of 1 is 1, over 8. So x equals 7 plus 1 divided by 8. X also equals 7 minus 1 divided by 8. So 8 divided by 8 is going to be 1. And then 6 divided by 8 is going to be 3/4. I have 3/4 and 1 as my solutions. Okay, let me carry on to the next page. This should actually be next. This table that tells you about your discriminant. So if the value of your discriminant, looking up here at this first row of this chart, if the value of your discriminant is greater than 0, so if you have a positive number, you're going to have two real solutions, and I'm actually going to expand on that just a little more. You're going to have two real rational solutions if the value of your discriminant is greater than 0. I wanted to come back here and insert this information. You'll have two real rational roots if it's greater than 0 and a perfect square. Now what that means is you will not have a radical in your answer. It'll just be two whole numbers, two integers, two fractions, something like that. If it's greater than 0 and not a perfect square, you're going to have two real irrational solutions, which means you will have a radical in your answer. So I apologize if this is after the other. No, it's before. I just inserted it in the video. So two real rational if you have a perfect square and it's greater than 0. Two real irrational if it's not a perfect square. And you will have a radical in your answer. If the value of your discriminant is equal to 0, then you're going to have one real rational solution. And then if the value of your discriminant is less than 0, meaning that it's negative, then you're going to have two complex answers. I know it says two imaginary solutions, but I like to refer to imaginary solutions as in the set of complex numbers. They're complex. You're going to have an I. Here's the reason. If your discriminant is greater than 0, then it crosses the x-axis, it being your quadratic, crosses the x-axis twice. If it's equal to 0, it touches the x-axis. If it's less than 0, then it does not touch the x-axis. Therefore, our solutions are imaginary solutions. Okay, so two real rational if it's greater than 0, one real rational if it's equal to 0, and two complex if it's less than 0. Now, let's go back to those first three examples because we're going to do those first three examples in a special order, and I'll show you what that is. Now, these say find the discriminant and describe the number and type of solutions of the equation. So for 4, 5, and 6, we do not actually have to solve. All we have to do is find the discriminant. To find the discriminant, you need to make sure it is equal to 0. So A is 1, B is 34, C is 289. I'm going to do B squared minus 4AC. 34 squared minus 4 times 1 times 289. So 1,156 minus 1,156, which is 0. So that is equal to 0, which means I'm going to have one real rational root. No radical in my answer. So it says, find the discriminant. Here's the discriminant. And describe the number and type of solutions of the equation. One solution, and it's real and rational. So that's the two answers for number 4. For number 5, I need to make it equal 0. I'm going to subtract 3 and add 8x. X squared plus 8x minus 3 equals 0. A is 1, B is 8, C is negative 3. So b squared minus 4ac, 8 squared minus 4 times 1 times negative 3, 64 plus 12, 86, and that number is greater than 0. It is not a perfect square, greater than 0, not a perfect square, so that means I'm going to have 2 real irrational roots, which means I will have a radical in my answer, but it will not contain an I. And same thing for number 4, I will not have an I when that happens. Okay, so for the next one, I'm going to subtract 3q first. 4q squared minus 3q plus 1 equals 0. A is 4, B is negative 3, C is 1. The discriminant is b squared minus 4ac, so negative 3 squared minus 4 times 4 times 1. 9 minus 16 is negative 7, so that's my discriminant. Negative 7 is less than 0, so now I'm going to have 2 complex solutions. Let's see what's next. Next, we're going to answer this word problem. Baseball player hits a foul ball straight up in the air from a height of 4 feet off the ground with an initial velocity of 85 feet per second. From that, we're supposed to come up with the quadratic function, and I've given you that quadratic function. I won't ever ask you to come up with a quadratic function from a sentence like that, but I can tell you that for the initial height, that's your y-intercept. The 85 feet per second will always be beside your t. And then this negative 16 is always your a value in these types of problems. So that's the answer to letter A. I'll always give you the equation though. And then it says, when is the ball 110 feet off the ground? So H stands for the feet. We're going to substitute 110 in for H and solve that. And since we're working with the quadratic formula, we'll solve using the quadratic formula. So we'll make it equal 0. 0 equals negative 16t squared plus 85t. Is that minus 106? A is negative 16, B is 85, C is negative 106. B squared minus 4 times A times C, 85 squared is 7,225. A negative times a negative is a positive times a negative is a negative, so minus 4 times 16 times 106. That's 6,784. $441 is what I get. So X, I'm not going to sing this time, so just going to fill it out. I know probably some of you are thankful, but that's okay. Negative b plus or minus the square root of b squared minus 4ac, all over 2a. So X is going to equal negative 85 plus or minus the square root of 441. Oh, and I forgot to mention, 441 is a perfect square. I think it's 21, but I think I'll check myself. Yes. So that's a perfect square, which means I'm going to have two solutions, but we'll look at those solutions here in just a second. All over 2 times a, so 2 times negative 16. And see, there's that a value negative. You all know I don't like that, but it's okay. X equals negative 85 plus or minus 21 divided by negative 32. My two solutions, x equals negative 85 plus 21 divided by negative 32. X equals negative 85 minus 21 divided by negative 32. Okay, so negative 85 plus 21, 64, negative 64 divided by negative 32. And that is going to be 2. And then negative 85, I think that's 106. Yeah. Negative 106 divided by negative 32. That's 3.31. Let's look at this scenario because both of those answers make reasonable sense. So let's see. So here is the baseball bat, and it's hit the ball. It's flying through the air. And it says, when is the ball 110 feet off the ground? So this is at 4 feet here, and this is definitely not the scale. So let's say 110 feet is, use red, I'll use another color. 110 feet is here. So in 2 places, the ball is 110 feet off the ground. Of course, it says when. That's how I know we're finding x or t here. And so there are 2 answers. Those 2 answers are 2 seconds. After 2 seconds, the ball is 110 feet off the ground. And after 3.3, we'll just round to the nearest tenth. After 3.3 seconds, the ball is 110 feet off the ground. And our reasoning can be explained by this picture here. That's how you know when the ball is 110 feet off the ground. This line here represents 110 feet. Okay, let's look at the next part. I can't erase that, that's okay. The catcher catches the ball 6 feet from the ground. How long is the ball in the air? The catcher catches the ball 6 feet from the ground. So feet is talking about height. So 6 feet in the air. And we want to find how long is the ball in the air. This is good. Okay, so I'm going to subtract 6. 0 is going to equal negative 16t squared plus 85t minus 2. And then I'm going to do the discriminant. A is negative 16, B is 85, C is negative 2. So 85 squared minus 4 times A times C. So 7,225 plus 128, no, minus. A negative times a negative is a positive, positive times a negative is a negative. So that is a minus 128. 7,225 minus 128, 7,097. Okay, so I'm going to fill in the quadratic formula. Negative b plus or minus the square root of 7,097. I don't think that's a perfect square, but it could be. No, it is not. Divided by 2 times negative 16. I sure did not leave myself enough room. So I have negative 85 plus or minus, and since I need an answer, a realistic answer, I'm going to round to the nearest hundredth. 84.24 divided by negative 32. We'll come up here to the top. So I'm going to have x equals negative 85 plus 84.24 divided by negative 32. And I'm going to have negative 85 minus 84.24 divided by negative 32. And then divide 0.02, or around the nearest hundredth, 2/100ths of a second. And then the other one, negative 82.362, and then I'm just going to divide by negative 32. 2.57. Okay, so I think you have to have some knowledge about baseball, and you all might have to help me. The catcher, isn't that silly? Isn't the catcher the one that's behind the base? I think that's right. So see, if you don't have any knowledge about baseball, and don't laugh because there are people who don't know. If you don't have any knowledge about baseball, this is difficult to find the answer. But I'm pretty sure that's where the catcher is. The catcher is behind the base with the batter and the umpire. So which one of these makes sense? Would the catcher catch the ball after 2/100ths of a second or after 2.57 seconds? Because remember, this is like doing an arc. So this would be like in the outfield, and this would be, 6 feet from the ground. This would be right when it's initially hit, or as it's going to be hit. So to me, this is the answer. 2/100ths of a second is when or how long the ball's in the air before the catcher catches it. Let me know if that doesn't make sense. I believe that's it. I hope you have a wonderful day.